Architectural Review is a national platform where science and art meets, where the issues facing builders and consumers take center stage, where the spotlight seeks out and shines on the creators and innovators. This editorial series, featured on national television, singles out architectural achievements from tools to technique, from form to function.
Environmentally Safe Products was handpicked as a featured guest because of its commitment to promoting progress in the world of architecture. Blazing heat and chilling cold are two of nature's primal forces and two of an architect's most formidable foes. Designing spaces to stay cool in summers and warm in winters is all part of understanding the science of insulation.
Insulation in buildings is intended to reduce the heat flow from hot surfaces to cold surfaces. Energy transfers because of temperature differences. The purpose of insulation is to slow down or intercept this transfer of energy from the hot surface to the cold surface, and there are a number of strategies for doing this. One of the oldest strategies is to put a bulk material between the hot and cold surfaces, and there are many varieties of insulation that fall into that characteristic.
Yet recent studies have shown that some of these materials can have a negative impact on indoor air quality and the environment. Consequently, an alternative to bulk insulation has been developed by modifying technology originally designed for the solar power industry. Engineers have adapted a reflective material that can be used for a variety of residential and commercial insulation needs. Much like the reflective glass found in a thermos bottle, its effectiveness is based upon the principles of radiant energy transfer and emissivity, or E values.
All building products have what they call an emissivity value. Emissivity is the ability of any surface to emit or transfer radiant energy to the other side. So in other words, how much radiant energy that comes in contact with any given building surface will transfer through.
Because of this, the lower the E value, the better. The material being applied here is shown to have an E value of 0.03.
Which means that 3% of the radiant energy that comes in contact with our pure aluminum surface will transfer through. The inverse of that is that 97% of that radiant energy will be reflected back out.
Property owners continue to express anxiety over the rising cost of heating and cooling and the potential risks of more traditional insulation. Contractors are finding that pure aluminum foil can address both of these concerns.
Well, actually, we'll use anything the customer wants, but we kind of push it because it's so much better than everything else, we feel. The R factor is so much better. If a consumer wanted to lower their energy bills, they would use low E along with energy efficient windows. Matter of fact, I think Florida Power gives you some type of break on that if you go with it.
Building spaces that can be as efficient as they are beautiful remains challenging, but a little applied science to the places we live and work is allowing architects to develop some cool ideas for hot properties.
The product is used everywhere across the nation and in various other countries internationally. And the reason being is whenever you're dealing with heat transfer, the thing to remember is that hot goes to cold. Okay? In any application, whether you're in a warm climate or a cold climate, you're looking to deal with the heat. The heat's either coming from the outside and you're looking to trap it outside of the home, or you have the heat on the interior of the home and you're looking to keep it contained inside the home. So it doesn't change whether you're in a warm or a cold climate. Either way, you're still looking to trap the heat and stop the heat from getting to the cold.
Well, being familiar with radiation gain and losses in designing solar panels and solar houses, we started looking at different reflective insulation products, and we wanted to build a better widget, something that was easier to use, higher quality, better performing type product than what was available. And after about 2 years of research, we designed the Low E product using a polyethylene foam core. Low E stops heat, deadens sound, and doesn't absorb moisture.
The feedback that we've received has been very positive with regards to our product for a number of reasons. One is that it's completely environmentally friendly. All right, all of the materials that go into the manufacturing of the product are non-toxic. There are no glues or adhesives. It's a flame lamination process, which ensures long-term lamination. The other thing is we use a closed-cell polyethylene, so there's no fibers or no formaldehyde, anything like that can get into the air. And the employees, the contractors who are working with it, typically are accustomed to working with something that is a little more labor-intensive. And being that you can fold it, mold it right around corners, on steel buildings, it's replacing blanket insulation, which this is obviously much easier to work with from a point of view of no masks or anything like that is needed.
Right now, approximately 15 to 20% of our product is post-consumer, a lot of it being recycled milk jugs that actually go into the product. Our goal is to one day to the core be 100% recycled. And more people are looking for this in their buildings to take advantage of what we used before and use it once again.
Once again, American Architectural Review extends a special thanks to the companies and organizations that have risen to meet the challenges of today's architectural industry. This has been a presentation of WJMK.